Hey guys, this is Mainak and you're watching Civil Bro. In this particular lecture, we'll be covering an entire building model using the Tekla Structural Designer. We'll do the structural design and from the very beginning, we'll start from the modeling part and then the load application, then the structural analysis and design, and including the foundation design. We'll apply the seismic and wind loads and your load combinations also, and we will show how to generate the drawings and generate the report during submission also. So all this will I'm going to squeeze together in a single video, so you can watch the video part by part. And as you progress in this video, just drop you can drop your progress in the comments, and if you finally reach to the end and learn the software, you can drop a heart in the comments. And if you have any doubts, obviously you can ask in the comments and I will make a video on that particular doubt. Okay, so let's start. So I had already made a video detailed series on ETAPS, so I'll be using some reference there. I'll be giving the playlist link in the description as well. You can check out for the detailed explanation of the IS codes. In this particular part, I'm not going to go very much deeply into the IS codes. I'm just going to refer all the things which I'm going to take. So first of all, let me introduce to you the building, your framing plan which we are going to make today. So this is the frame. Uh, Suppose you have an architectural plan, you need to place the columns first, and after you place the columns, you need to make this beam column plan. Tekla does have an option of your importing the center lines. We'll get into that. That is a very easy feature. But overall, if you have this particular grid line, we can also do it directly in the software. So we'll be dealing with that particular procedure, or that particular way rather, today. Okay, so we'll make this. Okay, so this building will be a G+3 building, ground floor and 3 floors above this particular building, and the height we can take as your 3.2 meters. So already you can see, in the height of the building, height of the floor to floor height, you can take as 3.2 meters. Okay, so we'll get into the details. So let's start. So this is the interface of the Tekla Structural Designer. First of all, what you need to do is you need to click on new, and if you are watching on YouTube, I'll suggest that you do the settings into the highest quality, so that you can see all the icons in detail. Okay, so once you click on new, the particular window opens up and you find one is structure 3D, which is obviously the 3D, and one is the base. So first thing we're going to do is we're going to make the levels. So we're going to go to model and then construction levels. So this is the base, as you can see, only level. So what I'm going to do, I'm going to click a insert below. So this will be foundation level. Now the foundation level is usually taken at a particular height when and the geotechnical engineer, or you find the soil test report from any firm, then that particular soil test report gives you a particular SBC at a particular depth. Suppose at 1.5 meter, the SBC is 150 kilonewton per meter square. So decide that, okay, I am going to go up to 1.5 meter, where I'll find the hard soil strata. So like this you do. So I'll do this as a minus 1.5 meters. That will be my foundation level, and my plinth level I have fixed at 0. So 0 is my plinth level or the base, and this is my foundation level. And I'm going to go a level above, and this will be, and the spacing which I'm going to give here is your 3.2 meters. So 3.2 meters for this, and this particular floor will be my ground floor slab for my first slab. So this will be SSL, or structural slab level. TOF means top of foundation or top of footing, and TOS is used for the steel structures, top of steel. So I'm going to use SSL here, structural slab level 3.2 meters. And slab thickness, we know that we have to calculate the slab thickness and all, but overall I'll provide a slab thickness of 150 mm. Later we can change this, but now we are providing because by default in G+3 building it's between 125 to 175 mm. I'm going with 150 mm. Okay, so a 150 mm slab thickness, and my ground floor is ready. I want two more floors above this. I'll just click on insert above and insert above once again. So this is G plus 1, G plus 2, and then you want G plus 3, then another floor. So G plus 3 building, all the levels have been created. So after all the levels have been created, just click on OK. And now you will find here in the left side, in the levels, there are all the levels. You can just go to any level by double clicking on it. Suppose I already have structure 3D and structure base open. So suppose I want to go to 1, I'm double clicking on, and then I have gone to 1. So like this, you can go to any level. So let's go back to structure 3D. And now, or if best it is, you can go to the structure base, or we'll start at the plinth level. At the plinth level, we'll start making our grids. So once we reach the plinth level, using our diagram or the centerline plan, we'll just make the grid lines. Okay, so we'll go to model, and then we'll go to this option here, and we'll use the rectangular wizard. So the first options don't matter, just click on next here, and then you have this option of regular and irregular. So we'll choose irregular, and in the irregular we'll just insert here 3.2 comma 3.3 in the x direction. This is the x direction, and next then in the particular y direction we will give here 2.1 comma 2.4 comma 2.1. Then just click on next and then finish. So we'll find the grids which has been created as per our diagram or the beam color plan. You can check here, click on measure, you can see this as 3.2, click on escape again, just click on this 3.3. So you can see here 3.2, 3.3, then 2.1, 2.4, 2.1. Just use measure again, select this, and you can see here 2.1. Let's click on escape, this 2.4, escape, then 2.1. So our grid is okay, and this grid, if you see, has been copied to all the floors. I've clicked on escape, and if you click on any floor, suppose the topmost floor I'm clicking on, so in all the floors the grid has been made here. So we'll go back to the plinth level because we are doing operating from here. So in the plinth level we want to insert the columns. So first of all, make sure you have selected the code of the country along which you want to design. So for that, go to home and go to model settings. Make sure you have selected the country. Here I am selecting India, and you can see all the Indian codes for the building design have been selected here. Just click on OK and save if you are changing this, and then click on settings, and here also you will select the, if you want to go by UK settings or you can use USA settings, you can do that. I have selected India settings, and if you want to add something which is not in this list, just click on import and you can find out the country. Okay, so these are the basic things which you need to know. And then for adding columns here, first of all go to columns. So I went to the models and then in the column. So what I'll do, I'll create a column first and I'll define the properties first. So let me go with 400 into 400 columns here. So here the size is already selected here, 400 into 400. If you were to edit this, suppose you were to give any other size other than 400, let me go with 400 to 450. So you'll go like this and click on OK. And if you want to place the columns at the center, you just untick this automatic alignment, then the columns will place to the center, and then you can make this as FE500, the steel grade, and cover automatically the takes as 40 mm, which is the default for the columns. Grade of concrete you can change M20, M25. So M20 is the minimum grade which is taken and most common, so you can use that. And after that, after having everything saved, just click on save here. So I'll do here C 400 cross 450, just to remember the name, and then click on OK. and then select from here, see 400 to 450, and then I can apply, left click and apply it one by one in case I have different columns, or else I can just simply left click here like this, and as you can see all the intersection has been selected and the columns will be placed. So if I have like this, so it will be placed like this. So if I had separate columns, I'll just put Ctrl plus Z. If I had separate columns, I could have placed it like this, okay, one by one, and then I could have defined another column, and then I could have placed, place the remaining columns as well. So what I'm going to do is I'm going to just select all the columns, and Tekla has got a very nice user interface. You can see in the structure 3D, and you can see this is mint. You can rotate this, just right click on your mouse, and you can see the columns which have been made. So it's very fine user interface. GUI is very good here. So now what you want to do, just click on escape. So next thing we want to do is the beams. So I'm going to beams here, and I'm going to define a beam here. So beam size I'm going to give here 250 into 400. This will be my beam size, and I'm going to click on OK. And after that, just going to change this to FE500, and also change this to FE500. And after this particular change, we're going to save this as B250 cross 400, and click on OK. And after that, you can select this B250 into 350, and this is the plinth level. So the beams will be here. So you can just left click here, and then left click here, like double click here to join the beams like this. Like this, you can join all the beams. But if it is a column to column beam, you don't need to join it like this. I'll press Ctrl plus Z, and you can just simply drag it like this. It will be joined. And in this case, since all are column to column beams, I'll press Ctrl plus Z again. You can simply drag it like this, and all the beams will be joined. So in all the positions where you have beams, you can join the beams. Where you have little bit more complicated beam column diagrams, you need to join them one by one. We'll go into that where we make our full project videos. So now you know how to make the beams. Check out in the structure 3D. This is the beam which has been made. So we'll go to the next level. Since this is the plinth level, it doesn't have any slab. So in the next level, we'll just go to structure 1. So this is my next level, and select the beam, and I'm going to take the beam section, and I'm going to same way I'm going to apply the beams. Next, what I'm going to do, I'm going to click on slab. Automatically 150 mm slab will be taken. Just left click on them, and the slabs will be taken here. Two-way slabs are taken as default. As you can see, slabs have been provided. So now this particular thing I can copy to all the remaining floors, since all the remaining floors will also have the slabs. So I can go to construction levels and make this source as 1, this also 1, and this also 1. 1 is the level, or the ground floor slab level, which I have just created. So if I click on OK, this particular floor will be copied to all the floors in a single go. Then we can go to construction levels again and quickly make this as unique, because all the changes which we'll do in terms of the loading, we don't want this to be copied to the other floors. So once it is unique, go back to construction levels and check that all are unique. This check is very important, because sometimes you might forget to make them back as unique. Next thing is about the loading part. So the loading part, I'm not going to take much time, as I've already explained in the ETABS videos about the IS codes and how to determine the loads. Just you can take a screenshot of this, of what are the loads we're going to take in terms of dead loads and live loads. Dead loads, the code for it is IS 875 part 1. We all know that. If you don't know, just remember this, and also watch the video in the ETABS part, so that you can know what are the basic things you need to remember and basic things you need to know about this code. So self weight, the software automatically takes. Wall load we're going to put in the particular software. For 10-inch wall, we're going to give 14 kilonewton per meter. 5-inch inner wall, 7 kilonewton per meter. For the parapet walls, we will go for 5 kilonewton per meter. And floor finish load overall, we're going to apply 1 kilonewton per meter for the floor finish. Live loads, we're going to take here 2 kilonewton per meter square. There's a mistake, so it will be 2 kilonewton per meter square as per IS 875 part 2 for the residential buildings. The detailed calculations are also there. You can take a screenshot of this detailed calculations, or if you want to know the explanation, go ahead and in the ETF playlist you can check the part on the dead and live loads. Okay, so you can do that. So we'll just apply all the loads as per this. Okay, so first of all, let's apply the wall loads. 10-inch wall load 14 and inner 7, and for the parapet 5. So let's do it now. First of all, let's go to the base, and we'll select here dead. And after selecting dead, we'll go here with you have this load option, full UDL, outer. Let's go with 14. Okay, just left click, left click, left click. So you're going to left click on all the outer beams where the outer walls will be there. You can check here in the bottom right. There is an option. Click here. So 2D to 3D. You can check the 14 kilonewton load has been applied. So now we'll change this to 7 and then apply it on the inner walls, or the beams on which the inner walls will be there. Check back the 3D. You can notice the level of the difference. So similarly, we'll go to the 1 here, and here also we'll apply select the dead load, full UDL, and here also there will be 14 in the outer for the 10-inch walls, and for the 5-inch walls go with 7. So load calculation, if you know how to calculate it, as per your varying wall thickness, you can calculate the loads. So in the dead loads also, I'll go with level load here, and for the floor finish, I'm going to apply 1 kilonewton per meter square. So I've selected this. So as you can see, floor finish of, then click on escape, floor finish of 1 kilonewton per meter square has been applied, and the wall load has been applied in this particular level. So in the structure 3D, I'll go here and I'll just select here, dead load. So as you can see, this is the particular dead load which is in this particular floor. If I want to copy in this next two floors, I can do this. I'll go to model, I'll go to construction levels, and for these two, I'll make this one and also this one. Click on OK. So these loads have been copied. Go to construction levels and make them back as unique. Click on OK. So in the top floor, I'll go here. Just level click on structure 4, top floor I've gone, and for the parapet wall, only along the parameter, I'll apply a load of 5 kilonewton per meter. So going to load and selecting here dead load, full UDL of 5, apply it for the parapet wall. And also floor finish load, it don't need to apply on it here because this will be the roof. So no need to apply the floor finish load. Now you go to structure 3D and you can check here the loads which you have applied. So we'll switch back to the imposed load and we'll apply the live load here. So we take a level load here of 2 kilonewton per meter square. So we'll apply it on all the floors, the live load. So once the live load has been applied and also the dead load has been applied. So you can do up to this and you can take a break and you can come after the break. You can take a cup of coffee and come after the break. So welcome after the break, and now what we'll do, we will move further into the other loads, which is the wind load and the seismic load. So explanation detailed I have given for the wind load and as well as the seismic load, which is wind load code is 875 part 3, and basically if you see, this is a building and the wind is acting here. So wind is a lateral load. So the direction in which the wind is acting, it is windward wall, and the opposite direction is the leeward wall. So there are wind coefficients which you need to apply here, and this is basically on the windward side is 0.8, and in the leeward side is 0.5. So you're going to remember that, and all the other details I've explained in the ETABS videos or the IS code part. You can just go through that. So in the 3D view, what we'll do, we'll go to our model and then we'll make our wall panels. So rectangular panels have been selected. Right click and obtain a suitable location for selecting. This corner selected, and then this corner, as you can see, this corner, if you select, this selection is not happening properly. You can see that. So rotate it properly, and after that just click on escape, and again then select the proper location and then select it like this. Similarly, do like this, rotate, and then select, and then select like this, select, and then select like this. Click on escape. So we have selected this particular wind panels, and can simply select decomposition, nodes, members, and rigid diaphragms. There are 3 options here. So do this as rigid diaphragm and ignore diaphragm. Here also make this as rigid diaphragm and ignore diaphragm here, because you don't want to consider this as the loads here. You don't want to consider just for taking the wind loads. We are considering this as diaphragm. So diaphragm and ignore diaphragm. Okay. So we have done on all the 4 sides the same thing. What you do, just validate the model, check whether everything is okay till now. So when everything is okay, just go to load here and open the wind wizard. So worst case data to be considered, and can ignore this, consider topography or consider cyclonic effect. Since if it's in a cyclonic zone, you can consider this, or if it's not in a cyclonic zone, you can uncheck this and just click on next. And orientation here, give 90, which means that the wind will act 90, 180, 270. So around all the 90 degrees it will act. Building height exposed to wind, maximum height it automatically takes, and then the basic wind speed is your 55 for Tripura, and I have already shown in the video on the wind of the IS code 875 part 3. You will find a table and also a map in which basic wind speed is located, and K1 and K2 factor will be 1 here for Tripura. And again, the detailed part, why this one, you can find out in the video on the tips part. So this is the same thing. So I'm going to repeat this, not going to repeat this, but basically you can just go through IS 875 part 3 for those factors. Just click on next, and the terrain category will be exposed terrain with few obstructions and terrain with numerously closed obstructions. So we're going to go with open terrain with scattered obstructions. Fetch distance is basically the distance where the wind patterns are the same. So I'm going to go with 5 meters. So this topography feature, you can take any topography feature, or you can also ignore this. If you want to ignore this, just consider none. Generally you can ignore this, so just click on none here, and then next. So you can see the K1, K2, K3 and K4 factor, they have taken automatically. If you want to change this, you can change this also. There is an option, but now you don't need to, because already you have considered all the things. So the design wind speed they have calculated. Then click on next here, and then click on finish. So after that, you can see this are the wind load cases and update zones, and then you have this delete wind. So wind load cases, we click here, and you can just click on add here. So 4 wind load cases they have taken here, and first go with 0, next with 90, and then with the 180, and then with 270. So the CP values they have taken, automatically, 0.3 they have taken here. Can edit the name, but the CP values which they have taken here, they have taken automatically. If you want to edit this, suppose this is the wind 0, which is coming from the 0 direction. So this is basically, as we know, this is basically, you can take this as 0.8, and from the leeward side, that is to the 90, you can take this as 0.5, and similarly for the 180 you can take this as your this 180. You can just check here which direction will be the 180 here. So if you just check here in this particular, if you let me draw a rectangle to explain. So if this is the 0 and this is the 90, and if in terms of axis here, and this is the x-axis and this is the y-axis. So here if you want to see here, this will be 0 and this will be 90, and this will be your 180, and this will be your 270. So coming, it will be like this. You can just verify this properly. You can just go here, and first of all I'll delete this, all these combinations, and click on auto. So we are going to add some wind load cases. Just click on this wind load cases. You can add this manually or just click on auto. So the CPI values you can see automatically in it as we get inserted manually. So then you can just click on OK. So after that, go to seismic load, go to seismic wizard, and then code spectra, and just make this ignore seismic below our plinth level. This, for this case, it's structure base, and then zone I'm going to design for Tripura, so it's in zone 5, and this is based on the IS 1893 2016 part 1. Site class is medium. Importance factor is 1 for the residential buildings. Again, if you check ITA's videos on the seismic, you can find out the detailed IS code explanations if you want that. And then damping is okay, and again have two options here. You have this equivalent lateral force procedure of the model response spectrum analysis. I'm going to use this model response spectrum analysis, and then click on next here. Structure type, you can find out here. You have this RC moment resisting frames, RC steel composition frames, buildings with RC structural walls, and all the buildings. So we're going to select here RC moment resisting frames here, and then click on next. And here also you have this moment frame systems. Here also moment frame systems. You can say select here. I'm going to select RC building special moment resisting frame here, and then click on next. Select all these. Imposed load and dead load, this seismic load takes into consideration. Then click on next. Then click on finish. Create some load combinations according to the seismic load. Click on next. The widget combinations have been selected automatically. Next, and then finish. Lastly, we'll go for the load combination as per the IS 875 part 5. Click on combinations and click on generate. Next, select this, and these are all unselected. These are working state stress method load combinations. Click on next, next, finish, and OK. Click on validate to check whether everything is okay in your building. So once you have done that, go to design and click on design all static. So as you can, the design has been done and all the members are safe here. In if you design by IS code, there is a a little bit problem that warning comes, but you can ignore this for the plinth level. Basically, all the members are safe. You want to see any design here. Suppose for this particular column, what is the design here? You want to see here. So just right click on this particular column and you can just use the check member static, and you'll see the results here. You can see 8 bars of 16 has been used right from the bottom story to the top story, and everything is safe here. Suppose for this particular beam, if you want to check the result here, just select this particular beam and right click, and then you can go with let's see, check member static, and you can see here 2 bars of 16 on the top, 2 bars of 16 on the bottom for the first span, so the second span, and for the first span, or the sorry, the second span, they have used the same thing. So like this you can do, and if you want to find out the drawing of this particular column, you can just right click on this, and you can see, click on generate drawing. If you want to give the location, just give the location here, or if you want to do the default location, just click on OK, and you'll find the drawing which will open directly in your AutoCAD. So this is the drawing which is opened directly in your AutoCAD. You can see the drawings here, 8 bars of 16 and if you want to see the tie detail, the tie is also placed here at 250. Center to center, the tie distance is a little bit more, but you can see the drawings have been generated along with the bar quantities also. So it's very helpful. And if you want to design the foundation here, just you can go to your option of your foundations, go to pad base columns, and if you want to just insert the SBC here, you can find out the option of your concrete class, and then your other things as well. And here you'll find the soil parameters. Just insert the soil parameters according to your soil test report, SBC, and soil unit weight if you want to change, and go to the settings, and in the settings, if you want to change anything, you can do that, like the reinforcement layout, the minimum reinforcement, maximum reinforcement. You can just change that, changes to 500, 10 mm, let's go, and the maximum also at 500, and then you can go here, let's go here 16, click on OK, and then just click on OK here. Okay, and then go to pad base column, and once you have inserted this and the soil parameters, just select all this entire thing, and then click on your design pad bases. Pad bases will be designed. So a warning will come here if you are designing with the IS code, but if you are designing with any other code, the warning will not come. So this is basically a glitch. The warning of development link comes. We can show you here. We can see here check member. So you can see development length warning count, but this is due to a software glitch, so you don't need to worry about that. Development length already they have considered, but the beauty is that the foundation layout you can find out, and economical pad footing designs also you can generate. So let's go now to the generation of report and generation of drawings. You can take a break and then you can come back. So welcome after the break. Go to draw and go to this our base or the plinth level, and after that, first drawing which you are going to find out is our column layout. Okay, so we're going to go, let's select this structure to the bottommost level, and here only the foundation and column are present. So we'll go first for the column layout. General arrangement will select, and this time we'll just select a particular place for storing everything. I'll select a particular my location here of the video, and let's go here. This will be our column layout. Okay. column layout. Click on save. Click on OK. So this is my column layout. I have all the names of the columns here. And next thing which you need is the column schedule or the column details. So just click on column schedule. Click on OK. Just change the location here to whatever location you want. Concrete column schedule name is OK. Just click on OK. So we have the column details here, the reinforcement and the details which has been used, as you can see here. So column details we have found out and the column layout which we have found out. Next, let's find out the foundation details. So we'll go with the foundation layout. Change the file location here and to our location. Foundation layout, click on save. OK. So we have this foundation layout. As you can see, unlike Stat Pro, it gives a very economical design. As you can see for the foundation, see these are very economical designs for the foundation. They take the unfactored load. So as you can see, 16 bars, 300 center to center. So this is very economical design for the foundation. That's what is a special feature of this software. Now for the next beam column plan, let's go to structure base and you can find out here the general arrangement drawing, and then obviously just give the file name, and this file name will be your plinth. We give here plinth beam column plan. Just click on save. Click on OK. So we'll find this plinth beam column plan. If you want to do the beam details, you can also find out. So suppose you have to the beam details of CR B2 D2. So for that you have to find out the beam schedule. We just go here and just insert the beam schedule. I'm just giving the location. Save, click on OK. You'll find the beam details which the software calculates. As you can see, this is the beam details. Bottom bar 2 bars of 16 mm and top also 2 bars of 16 mm. In the stirrups, 8 mm stirrups at a spacing of 125. So pretty economical and practical design the software has given. So like this we can find out for the remaining floats as well. So now I'll go to the report here. If you want to generate the report, and suppose all this report you can generate. Suppose I want to see the material takeoff, material listing, and then select show report. We'll convert it into PDF. I'll go to the last page and I'll show you the total quantity which has been used here. Reinforcement 7.4 tons used in this building, the rebars and the concrete, you can see 82.3 meter cube. So again, this is very helpful. And also you have the other reports. You can find out the building design, and you can see the building loadings which you can submit if you're approving this building from a government. You can use this and just click on this PDF option, and then it will be converted into a PDF. So these are the things which you can basically do. And if you want to see the bending moment, shear force for any particular beam, just select a beam and just click on open load analysis view. You'll find the bending moment and shear force diagram of that particular beam. Going back to your structure 3D, and there are a lot of things, other things which you can do and which you can check, and those things in detail we'll make videos on that. And if you like this video, make sure to leave a like and keep learning wherever you are. Stay safe and stay happy. Bye bye.